So the first benefit really is reduced hardware. So you can take a physical system and create many virtual machines on it and compact it, so increase server density. So you're consolidating systems, you're using systems you already have, putting all of the cores that you have on the system to use. You increase utilization. Again, as part of packing this together, you are increasing the level of utilization for a particular system. Virtualization technology, and I put this in quotes, virtualization technology provides an easy way for you to set up high availability and disaster recovery for systems that are configured within virtual machines. It's easy, but it's not easy. You have to do quite a bit of planning and implementation, but they give you some ways to do it, so that's good. It's a good start. Virtualization allows you to quickly provide machines to people that need machines today. So you don't have to go out and buy a new machine. You don't have to go out and set up a new machine. You don't have to go out and provision all of that. You just create a virtual machine quickly. Okay. Virtualization provides some technologies to be able to have zero downtime maintenance. And we've actually tested some of this. There's a way that you can take a running virtual machine with a lot of users connected to that virtual machine and kick off a migration of that machine, that virtual machine, to another physical system. It can take hours, it can take days, but eventually all of your users will continue to be running and they'll all be migrated over to another physical system, and then you can shut down the original physical system, do your maintenance, etc. So they provide some pretty interesting technologies in that area. But at the end of the day, you really have to define the benefits of virtualization by what virtualization means to you in your organization. Why are you using virtualization? Okay, this slide just basically talks about some of the common options. There are many here, there are many more that are not listed. I'm sure you've heard of a lot of them. For the purposes of this discussion, all we're going to do is just talk a little bit about VMware. This is not an endorsement for VMware. We're not saying we're certifying it. It's just that we have some recent examples using VMware. So we'll talk a little bit about VMware and some of our experiences with it. Okay. Previously, we had found that the performance of cache and ensemble inside a virtual machine was not very good. And Intel has gotten together with VMware and worked very hard to create an environment in which performance of virtual machines is a lot better. But what we found is that it's a combination of both the advances that Intel made in the CPU architecture and the advances that, for this example, VMware made in their virtualization software. You cannot have one or the other and still achieve good performance in a virtual machine. You need both. Is our experience. Okay? Some things that impact performance in general from virtualization, from a configuration standpoint. We touched on the CPU. The CPU type is important. Memory. Virtual machines like to have a lot of memory. Okay? You have a lot of memory configured on a system, the hypervisor is going to perform well. If you oversubscribe, which means that you have 8 gigabytes on a system, physical, and you have 8 virtual machines, and each of them are assigned 8 gigabytes each, that's called oversubscription. The hypervisor can get into trouble in those sorts of situations because there's a lot of paging and you can have bad performance. So don't oversubscribe. Disk, there are a couple of different options when you're talking about virtualization. You can have virtualized disk, so in this case VMFS, because it's VMware that we're discussing, or you can have raw device mapping. At the end of this presentation, I have a link to a PDF file, and you can Google it. You don't have to type in the whole thing. VMware provided a comparison of the virtualized disk to the raw device mapping from a performance standpoint. And one has benefits for specific workloads and the other has benefits for other types of workloads. So consider the workload as well. We talked about VMFS, remote or raw device mapping, maybe better for sequential type operations. And again, this is in that PDF file. Virtualization technologies provide HA features. There's some examples here. vMotion is what I described to you that allows you to take a running system and migrate it slowly over to another physical system so you can perform maintenance. There are HA solutions built into some of these virtualization technologies that say if my main system goes down, then have this other system take over, sort of like a clustering. Okay, so I'm going to talk a little bit about this case study. So the track care site that was deployed with VMware, the 3-node ESX cluster using the latest Intel processors, we said is important for performance, and it has an HP SAN. It's using ESX4, which is the minimum version for good performance. And this diagram basically just shows that you have a system here. There are 3 app servers. They're in a virtualized environment, and the database server is physical. There's a management server over here, and there's shared storage or SAN that's used by the database server and by the virtualization technology. Okay? Now, everybody get ready for this great animation. Kaboom! Right? Main system, one of them blows up. There's big flames and fire coming out of them. As part of this, what happens is that the virtualization hypervisor detects that this system is no longer available. So it took the app, one of the app instances from there and moved it to this host, and the other app instance from there and moved it to this host. So now, each of these virtual machines are running 3 app instances instead of the previous case where each was running 2. So the load has been shifted to the available system by using the HA technologies that are built in to VMware. Okay, so this is a VMware HA case study example. Okay, and the last thing that I want to talk about is a recent benchmark that we did. It's a pretty complicated diagram, but it's actually pretty simple. There was an HP system that we were testing on. It was a DL980 with 8 processors, 64 cores, 1 terabyte of physical memory. This is the DL980, very big system. Okay, we had a EVA as a SAN, so some very good storage down there, and the system was connected to the EVA using fiber. Okay, we created a bunch of virtual machines on this DL980 using VMware as a hypervisor. Each of these virtual machines had 8 virtual CPUs, 32 gigabytes of RAM. We used VMFS as the file system, and we were running SUSE, SUSE Enterprise Linux 11 Service Pack 1 64-bit version as the guest operating system. Okay. There's some configuration information here about the internal disks. So the HP system had some internal disks that was configured RAID 5, etc. VMFS volume was configured 1 terabyte ones, and we can provide all of those information to you for configuration. But basically, the moral of the story with this particular benchmark was that the performance and the scalability were superb. They were excellent. With 4 virtual CPUs, we were able to sustain about 2,000 users. With 8 virtual CPUs, we were able to double that. So we doubled the number of virtual CPUs, we doubled the number of users we could sustain. That's great scalability. And from a performance standpoint, we found that 8 physical processors with no virtualization, with 4,000 users on a machine that was bare metal, no virtualization, the numbers were about the same as with virtualization. So that's a great testament to the performance implications of virtualization. It's come a long way. Okay? There's some references here. Again, I know you have a handout version of this, but you can Google some of this stuff and find it. And I'm available for the rest of the day for any questions. And thank you for attending.